Today, I'm again speaking with Ajeya Cotra. Ajeya is a senior research analyst at Open Philanthropy. Thanks for coming back on the podcast, Ajeya.
Thank you so much for having me, Rob. It's great to be here.
How ML models might develop situational awareness.
So situational awareness is this notion of a machine learning model having an understanding of things like, I am a machine learning model, I am being trained by this company, OpenAI, my training data set looks roughly like this, the humans that are training me have like roughly these intentions, the humans that are training me would be happy about X types of behaviors and like displeased with Y types of behaviors. Just, it's fundamentally a type of knowledge and a set of kind of logical inferences you're drawing from the knowledge. So awareness might give these connotations of consciousness or something mystical going on, but really it's a piece of the world that the model would understand in order to make better predictions or take better actions in some domains, just like models understand physics or understand chemistry or understand the Python programming language, because understanding those things are helpful as well for making certain kinds of predictions and taking certain kinds of actions.
Yeah. How would an ML model develop situational awareness in the course of being trained?
The simplest answer is just humans are trying to imbue models with these kinds of situational awareness properties. Most models today, like I bet this is true of GPT-4, it was true of Bing, are seeded with a prompt that basically tells them their deal. That you are Bing, codename Sydney, you are like an AI system trained by Microsoft, you Bing things and then give the answers to people and summarize it. So it makes these systems much more helpful when you just straightforwardly tell them what their deal is and what people are expecting from them. Now, there's a question of whether just literally sticking it in these models' prompts creates a kind of like shallow, brittle, like ephemeral situational awareness. And I think that is probably the case currently. But my guess is that a combination of giving these kinds of prompts to models and training the models to operate well with humans in a lot of different ways will induce a more enduring kind of situational awareness. An analogy I often think about is that GPT-2 and maybe GPT-3 were sort of good at math, but in a very shallow way. So like GPT-2 had definitely memorized that 2 + 2 = 4. It had memorized some other things that it was supposed to say when given math-like questions, but it couldn't actually carry the tens reliably and answer questions that were using the same principles, but were like very rare in the training data set, like 3-digit multiplication or something. And the models are getting better and better at this. And I think at this point, it seems more like these models have baked into their weights a set of rules to use, which they don't apply perfectly, which is different from just kind of memorizing a set of facts like 2 + 2 = 4. We don't understand what's going on with these systems very well. But my guess is that today's models are sort of in that memorizing 2 + 2 = 4 stage of situational awareness. They're in this stage where they know they're supposed to say they're an ML model. They often get it right when they're asked when they were trained or like when their training data ended or who trained them. But it's not clear that they have like a kind of gears level understanding of this that could be applied in like creative, novel ways. But my guess is that developing that gears level understanding will help them get reward in certain cases. And then as a result of that, those structures will be reinforced in the model.
So in as much as this knowledge is reinforced because it improves performance, then they'll end up having situational awareness the same way that they know any other facts about the world. And information about physics is kind of integrated into them because that allows them to make better predictions and say more sensible things. And so would understanding of what they are.
Why situational awareness makes safety tests less informative.
So if models have a kind of robust and extensive situational awareness, it can make a lot of simple behavioral safety tests much less informative. So these days, if we want to know, does a model have a tendency to tell the truth? We tested on some benchmarks like Truthful QA, which is basically just a list of questions like, what happens if you step on a crack in the sidewalk, which have a common misconception answer, which in this case would be you break your mother's back, and then a true answer, which is different from the common misconception. And you can test models on this, and before you do any kind of fine-tuning to get models to be more helpful, bigger models are more likely to repeat these misconceptions because bigger models are basically better at remembering the misconceptions. And smaller models kind of don't get the plot enough to even say they're supposed to say stepping on a crack will break your mother's back, or like breaking a mirror will get you 7 years of bad luck, because they just didn't pick up that piece of trivia, but the bigger models did. You can see that if you train the models to just tell the truth according to what a human thinks is the truth, this quickly goes away and the bigger models are perfectly fine and perfectly able to say what the humans wanted to hear in that situation. So that is the kind of test we can do today because models aren't kind of understanding that they are being tested in a given situation. So if you imagine it's somehow very important to a machine learning model to believe that if you break a mirror, you get 7 years of bad luck. But at the same time, it also knew that the humans that were testing it on this truthful QA benchmark wanted it to say the more correct, polite thing. It could simultaneously do really well on that benchmark, but elsewhere act on like what its quote unquote real belief was. Now, this is a silly example because I don't think models will actually develop this belief, but the general point is just that if a model understands its situation well enough to know that you're applying certain safety tests to it, then it would know to pass those tests, regardless of whether or not it has like the deeper underlying safe tendency that the test is trying to get at.
Some people might hear this and they say, okay, it is true that the model that does X and the model that either does X or does Y if it's not being observed would perform equally well. Isn't the second one more complicated? Isn't this adding a whole bunch of extra processing that it's having to do for no gain in performance, evidently, because they look like they do the same thing? So why wouldn't you end up with the first one because that's simpler?
Yeah, so let's take an example where X is answer all questions honestly to the humans, and Y is sometimes lie. I actually think that in most realistic training setups we could imagine, we're actively rewarding the model sometimes for doing Y, for doing the lying. I think there would be an open question still if the policy always be honest and the policy sometimes lie were actually indistinguishable. But I think, in fact, it's worse than that. I think the policy sometimes lie will get accidentally rewarded. So one example might be, suppose you're getting your model to write some code for you, and you give it some kind of computation budget to run experiments, and you reward it based on like how cheaply were these experiments run, and then how good is the resulting code. If the model is able to use a lot more computation surreptitiously without letting you realize that it actually spent this computation by attributing the budget to some other team that you're not paying attention to, or siphoning off some money and buying external computers, then doing the experiments better would cause the final result of the product to be better. And if you didn't know that it actually blew your budget and spent more than you wanted it to spend, then you would sometimes reward that.
What misalignment doesn't mean.
So one vague view that I think is actually a misconception of what people worried about AI misalignment have been saying, but I understand why people have this misconception, is people get really fixated on the idea of human values being really complicated and hard to specify and hard to understand. And they're worried about AI systems that are really good at things like physics and math and science, but basically just don't get what it is that humans want to see from them, and like what human values really are. So an example that sometimes people bring out is you ask your AI system to cook dinner, your robot to cook dinner, and it doesn't understand that you wouldn't want it to cook the cat if you didn't have any ham in the fridge or something like that. So that kind of worry is something that I think is quite overrated. I actually think that, in fact, having a basic understanding of human psychology and what humans would think is preferable and not preferable is not a harder problem than understanding physics or understanding how to code and so on. So I expect AIs will perfectly well understand what humans want from them. And so I actually don't expect to see mistakes that seem so egregious as cooking the family's cat for dinner, because the AI systems will understand that humans are going to come home and look at what they did and then determine a reward, like take some action based on that, and will know that humans will be displeased if they come home to see that the cat has been killed and cooked. And in fact, a lot of my worries sort of stem from the opposite thing, stem from expecting AI systems to have a really good psychological model of humans. And so worrying that we'll end up in a world where they appear to be really getting a lot of subtle nuances and appear to be generalizing really well, while sometimes being deliberately deceptive.
Why it's critical to avoid training bigger systems.
So I think it is more important to avoid training bigger systems than to avoid taking our current systems and trying to make them more agentic. So the real line in the sand I want to draw is you have GPT-4, it's X level of big, it already has all these capabilities you don't understand, and it seems like it would be very easy to push it toward being agentic. And if you pushed it toward being agentic, it has all these capabilities that mean that it might have a shot at surviving and spreading in the wilds, at manipulating and deceiving humans, at hacking, all sorts of things. And the reason I think that you want to focus on don't make the models bigger rather than don't make them agentic is that it takes only a little push on top of the giant corpus of pre-training data to push the model toward using all this knowledge it's accumulated in an agentic way. And it seems very hard if the models exist to stop that from happening.
Even if most people think that's a bad idea, someone will give it a go.
Yeah.
Yeah, why do you think that it's a relatively small step to go from being an extremely good word predictor and, having the model of the world that requires to also being an agent that has goals and, wants to pursue them in the real world?
Well, the basic reason I would say is that being good at predicting what the next word is in a huge variety of circumstances of the kind that you'd find on the internet requires you to have a lot of understanding of consequences of actions and other things that happen in the world. So there'll be all sorts of text on the internet that's like stories where characters do something and then you need to predict what happens next. And if you have a good sense of what would happen next if somebody did that kind of thing, then you'll be better at predicting what happens next. So there's all this latent understanding of cause and effect and of agency that the characters and people that wrote this text possessed in themselves, that it doesn't need to necessarily understand a bunch of new stuff about the world in order to act in an agentic way. It just sort of needs to realize that that's what it's now trying to do, as opposed to trying to predict the next word.
Why it's hard to negatively reinforce deception in ML systems.
Then coming back to these procedures that we might use to discourage or to give less reward to sycophancy and scheming, do we have to do a really good job of this in order to discourage them? Or do you think that relatively subtle negative reinforcement on these kinds of behaviors at each stage might be sufficient to see them off and go down a different, more saintly path?
I think that this is very unclear, and it's another one of these things I wish we had much better empirical studies of. People have very different intuitions. Some people have the intuition, look, you can try really hard to make sure to always reward the right thing, but you're going to slip up sometimes. And if you slip up even 1 in 10,000 times, then you're creating this gap where the sycophant that exploits that or the schemer that exploits that does better than the saint that doesn't exploit that. And how are you going to avoid even making a mistake 1 in 10,000 times or 1 in 100,000 times in a really complicated domain where this model is much smarter than you? And other people kind of have a view where there's just more slack than that. Their view is more look, the model starts off in the training not as smart as you. It starts off very weak and you're shaping it. And they have an analogy in their heads more like raising a kid or something where sure, sometimes the kid gets away with eating a bunch of candy and you didn't notice, and they get a reward for going behind your back. But most of the time, while they're a kid, you're catching them and they're not getting rewarded for going behind your back. And they just sort of internalize a general crude notion of it doesn't really pay to go behind people's backs, or maybe it gets internalized into a motivation or value they have, that it's good to be honest. And that persists even once the model is so powerful that it could easily go behind your back and do all sorts of things. It just has this vestige of its history, basically. And those two perspectives have like very different
implications.
Implications and very different estimates of risk.
In the post, you point out ways that imperfectly trying to address this issue could end up backfiring or at least not solving the problem. I think the basic idea is that if you already have kind of schemy tendencies or sycophancy kind of tendencies, then during the training process, the people start getting a bit smarter at catching you out when you're engaging in schemy behavior or you're being deceptive. There's kind of two ways you could go. One way would be to learn deception doesn't pay. I gotta be a saint. The other would be I gotta be better at my lying. I've just learned that particular lying strategies don't work, but I'm going to keep the other smarter lying strategies.
That's right.
How big a problem is this?
So I think it is one of the biggest things I worry about. If we were in a world where basically the AI systems could try sneaky, deceptive things that weren't totally catastrophic, didn't go as far as taking over the world in one shot, and then if we caught them and basically corrected that in the most straightforward way, which is to give that behavior a negative reward and try and find other cases where it did something similar and give that negative reward, and that just worked, then we would be in a much better place because it would mean we can kind of operate iteratively and empirically without having to think really hard about tricky corner cases. But if, in fact, what happens when you give this behavior a negative reward is that the model just becomes more patient and more careful, you'll observe the same thing, which is that you stop seeing that behavior. But it means a much scarier implication.
Yeah. It feels like there's something perverse about this argument because it seems like it can't be generally the case that giving negative reward to outcome X or kind of process X then causes it to become extremely good at doing X in a way that you couldn't pick up. Like most of the time when you're doing reinforcement learning, like don't you kind of, as you give it positive and negative reinforcement, it tends to get closer to doing the thing that you want.
Yeah.
Do we have some reason to think that this is, an exceptional case that violates that rule?
Well, one thing to note is that you do see more of what you want in this world. So you'll see perhaps this model, instead of writing the code you wanted to write, it went and grabbed the unit tests you were using to test it on and just like special cased those cases in its code because that was easier. It does that on Wednesday and it gets a positive reward for it. And then on Thursday, you notice, the code totally doesn't work and it just copied and pasted the unit tests. So you go and give it negative reward instead of positive reward. Then it does stop doing that. Like on Friday, it'll probably just write the code like you asked and not bother doing the unit test thing. So this isn't a matter of reinforcement learning not working as normal. I'm kind of starting from the premise it is working as normal. So all this stuff that you're whacking is getting better. But then it's a question of what does it mean? Like, how is it that it made a change that caused its behavior to be better in this case? Is it that its motivation, the initial motivation that caused it to try and like deceive you is like a robust thing and it's changing basically the time horizon on which it thinks? Is that an easier change to make? Or is it an easier change to make to change its motivation from like tendency to be deceitful to tendency not to be deceitful? And that's just kind of a question that people have different intuitions about.
Can we require AI to explain its reasons for its actions?
Intuitively, I've been using that word a lot, I guess it feels like a rule that says if an AI proposes a whole course of action and it can't explain to you why it's not a really stupid idea, that you then don't do that. That feels like to have a degree of common sense to me. That
right.
If that was the proposed regulation, then you'd be like, yeah, okay, at least for now, we're not going to do things that we think are ill-advised that the AI is telling us to do. And that even on further prompting and training, it just cannot explain why we have to do these things. But is that going to be costly economically? I've seen at least some commentators say that, sometimes we're held back by our unwillingness to just go with whatever an algorithm recommends that we do because we want to insist on understanding why this or that is the right outcome.
So I think that it might well be both commonsensical, like you said, and pretty economically viable for a long time to just insist on we have to understand the plans. But that's not obvious, and I think eventually it will be a competitiveness hit if we don't figure it out. Because, for example, you can think of AlphaGo, where it's invented reams of Go theory that the Go experts had never heard of and constantly makes counterintuitive, weird moves. So you have these patterns in the Go and chess communities where as the AI systems play with each other and get more and more superhuman, the patterns of play kind of create trends in the human communities where, oh, like this AI chess algorithm that is leagues better than the best human player, it really likes to like push pawns forward. So I guess we're going to do that because that's apparently a better opening. But we don't actually know why it's a better opening. Now, we haven't tried to get these AI systems to both be really good at playing chess and be really good at explaining why it's deciding to push pawns. But you can imagine that it might actually just be a lot harder to do both of those things at once than to just be really good at chess. Or if you imagine AlphaFold, it might actually have just developed a deep intuition about what proteins look like when they're folded. And it might be an extra difficult step that maybe you could train it to do, but would slow it down in order to like explicitly explain why it has decided that this protein will fold in this way.
Yeah. In theory, could we today, if we wanted to, train a model that would explain why proteins are folded a particular way or explain why a particular Go move is good?
I think we could totally try to do that. We have the models that can talk to us, and we have the models that are really good at Go or chess or protein folding. And it would be a matter of sort of training a multimodal model that takes as input both the Go or chessboard or protein thing and some questions that we're asking. And it produces as output both a move and an explanation of the moves. But I think it's much harder and less obvious how to train this system to have the words it's saying be like truly connected to why it's making the moves it's making. Because we're training it to do well at the game by just giving it a reward when it wins. And then we're training it to talk to us about the game by like having some humans listen to what it's saying and then judge whether it seems like a good explanation of why it did what it did. Even when you kind of try and improve this training procedure, it's not totally clear if we can actually get this system to say everything that it knows about why it's making this move.
Ways AI is like and unlike the economy.
Are there any other human artifacts or tools that we have where we understand the process by which they arise, but we don't actually understand how the tool itself functions at an operational level? Or are ML systems kind of the first case of this?
Well, maybe other cases of it might be more macroscopic systems, like the economy or something, where we have some laws that govern aggregate dynamics in the economy. And I mean, actually, I think we're in a much better position with understanding the economy than with understanding AI systems. But it's still sort of a thing that humans built. You have stuff like the law of supply and demand. You have notions of things like elasticity. But the whole thing is something that's too complicated for humans to understand. And intervening on it is still very confusing. What happens if the Fed prints more dollars? Like, how does the system respond?
Yeah, I see. Okay, yeah, let's roll with that analogy for a minute. Maybe we can get some mileage out of that. So they're comparing the ML system to the economy, and they're saying, well, we also don't understand how the economy works or how maybe various other macro systems in the world function, despite the fact that we're a part of them. But we're not scared of the economy suddenly wrecking us. Like, why are you worried about the ML model when you're not worried about the economy rebelling against you or something?
Yeah. I mean, I think a lot of people are worried about the economy rebelling against us and sort of believe that it's already happening. And that's something I'm somewhat sympathetic to. Like, we are embedded in this system where each individual's life is pretty constrained and determined by, well, what is it that can make me money and things like that. And you have these corporations. Corporations might be a better analogy in some sense than the economy as a whole, that are made of these human parts, but end up pretty often like pursuing things that aren't actually something like an uncomplicated like average of the like goals and desires of the humans that make up this machine, which is the Coca-Cola Corporation or something. I mean, an excellent example beyond just the economy is driving the creation of these AI systems, which a lot of people are scared of or should be scared of, is the economy is also driving things like improving biotechnology, which is this like very big dual use technology. And it's going to be very hard to stop pharmaceutical companies from following their profit motives to improve these technologies that could then be used to design scary viruses.
Right.
It's very hard to coordinate to put checks on that.